Yesterday in the morning session, we learned about how to create geometry because geometry creation is the step number 1 in the CFD solution procedure. And now in this morning session, we will learn about creating mesh, which is the step number 2 in the CFD solution procedure. Yesterday in the second half, we solved very simple problems. Okay, there we have seen how we created the mesh. But please note that mesh is the most important part in the CFD solution procedure. If your mesh is done properly, that means more than 50% of your task is done. You can say 70-80%, because if the mesh is inappropriate, then what will happen? Your solution convergence rate will be very slow. That means it will take more time to converge. And in many cases, the solution may never converge. That means the solution will diverge. That means you will not get a correct solution. So therefore, most of your physical time and brain time must be dedicated towards creating the best mesh for the particular geometry. So now I request our speaker, Jishnu, who will deliver this talk. Yesterday also he was our speaker, where he explained in a nice manner for treatments of geometry creation by considering 2 examples. So now I request Mr. Jishnu to take over the session.
Yeah, thank you, sir. Thank you so much. So, sir already explained that for today's session, we are planning to have look on how the mesh works and what are the things we have to be, we can control on meshing, how to do a meshing, and factors, how these going, what are these type of factors going to affect the quality of the mesh. So I'm going to explain today's session. Shall we wait for one more minute, or else we can start? The people are just 33 only. Can we start, sir?
Yes, so you can start. Just I am again rewriting, requesting offline participants already joined. So online participants, 30 people joined. So I am posting it. Hopefully they will join it in a minute.
Okay, sir. Okay. So first of all, I'm going to share my screen. So first of all, we need a geometry for that. So I'm going to create a geometry. It's a simple geometry for a pipe flow. So for that, just creating a geometry. So you can create your own geometry. Don't give. I'm not going to give any type of dimensions of thing. According to you, you can model a circular cylinder and a connection. So I'm simply modeling a simple geometry right now with space plane. So in the meantime, can we get back into demand? Any doubts in the previous session I covered? Anything you can ask me in the geometry or any geometric preparation thing. You can ask me. Anything you can ask me on here. In the meantime, the space plane is open.
So participants having any doubt regarding creation of geometry, you can ask.
Yeah.
Hello. Hi, sir.
Hello.
Am I
Sir, I have
audible,
a
sir?
doubt regarding the enclosure. So
Okay.
yesterday in the heat sink problem,
Yeah.
when we created the second geometry,
Ah.
the lower part of the geometry. So if we create the lower part of the geometry, does the enclosure readapts itself to make the distance 50 we kept below? So if we create the lower geometry, then from that distance the enclosure 50 is created, or we have to recreate the enclosure.
Uh, the enclosure will give something like first time it's giving some value, then you have to be automatically we have to manually adapt this enclosure. So we have to give our dimension according to our problem, we can specify. So you have to manually add it on.
Okay, thank you.
So, any other doubts?
Sir, am I audible?
Yeah, audible. Yeah.
So I was asking that, sir, मैं हिंदी में पूछ सकता हूँ?
I don't know much Hindi, so you can
Okay, sir.
tell.
Sir,
Sometimes I
I was
understand
asking,
sometimes. Yeah.
sir, I was asking that you made two drawings in yesterday's session,
Yeah.
but I am very good in CATIA 3D software. So
Yeah.
if I made all those drawing in CATIA, do I need to specifically learn to draw it in on specific?
No need for that. Space time is so what the purpose of space claim in Ansys Fluent itself? So that it's an easier method. So that's why they adapted space claim. If you have a specific knowledge in any other 3D modeling software, you can do one there, and then you can export that geometry in a particular formation, and you can import that in here as well. So no problem if you don't have to know or don't have to learn more about the space time, you can do it on any other 3D geometry and you can import it.
Sir,
Okay, so I think now that out, so I can get into space geometry. So I'm going to create, um, first of all, I'm going to create a um, circle with 35 mm and I am going to create this. It's like uh, it's like a mixing problem, so that's what else you can add. Yeah, and in the middle of the this particular cylinder, I'm going to add another a plane in the middle of here. So I'm clicking here, this selection tool, I'm clicking on the y-axis and creating a plane there. And I'm going to move this plane to a 80 mm. And then there I'm going to create a geometry out there. It's about you, and we can specify like and you know tab. Problem you can create anywhere in here, and I'm going to create a circle to define and sketching. So here I'm going to state a pull up to the surface, so you can see this one. And after that, I'm selecting this and deleting this plane. Yeah. Here is one more thing we can do on this space plane. We can rename the section. I think in yesterday's session, you guys done the meshing and you guys named each of the thing like inlet, outlet on the meshing interface. So here as well, you can do the uh, can do named selection here. So if we need something like if this is a problem, I'm going to explain. This is a problem, it's a mixing problem, and this problem contains that flow of liquid, any liquid. Like I'm going to give this as water flowing with a 20 meter per second speed and with a temperature of 100 degrees Celsius. And here it's a much cooler fluid like 20 degrees Celsius and any other velocity magnitude. So this is like a problem which discussing about the mixing problem, mixing of two fluids, water and as well as any other fluid. Or else water itself, water with a low temperature and water with a high temperature. So we are going to simulate, the purpose of our model is to simulate how the fluid mixing is happening. So that's it. So here we need to specify each and everything, right? So first of all, I can create named selection from here itself. So I'm going to give this as inlet, and this as a hot inlet, this as the cold inlet, and this as the outlet, and specifying these are holes. So while clicking on here, clicking any space, and we can go into this option on the structures. uh, Below this tree, you can see structures, layers, selection, groups, and views. On these groups, you can see something, create NS. NS means name selection. So you can directly open it up with the Control plus G, or else you can click here. And I'm going to create this as a name that I'm going to name it as hot inlet, and here. Control G, and again it does bold inlet. uh, Here I'm going to create it as with Control G, Control plus G, and making it as outlet. Specifying these two as just walls. Yeah, that's it here, and that's about in the space thing. We can rename these one. So these are the namings we provided. I'm going to close this one. We can create any geometry, anything which a dimension is not constant here. We're going to do a meshing. According to a meshing, you can choose your mesh dimension or mesh size. So you can choose any of the value for the diameter and the length of this pipe. So here I created a geometry. Then you can do is why I just created a single group like this, because we can compare with the geometric creation meshing with the fluent meshing and as well as the ordinary meshing. So I'm going to connect this mesh with this geometry right now. So here I'm going to edit this. Okay. So here you can see our name selections are available here. So what we done on the space clay, it's affected here. So the one of the peculiarity of doing mechanical meshing is that you can, if any changes in the naming, you can use that in, you can edit that in the mechanical meshing. But in fluent meshing, it's not possible. So comparing with fluent machine, we have to do the whole naming of this part should be done on our 3D modeling itself. So that's the thing. Comparing with the mechanical machine and fluent machine, that's an important parameter. 1 minute here. Yeah. Okay. So you can see our name selection here. If you have to add any other name selection, like one was thing in machine. So I'm starting from the naming itself. So we created a name. So whenever we getting into machine interface, first do a machine. So while clicking on this machine, you can see some options here. That geometry settings, element quality, and things like that. I'll explain that later. So you can specify the preferences if I'm going to do any other thing like we just in the workbench we just created only. So in the workbench we create only geometry. We don't specify which name it is. If we created a geometry in a particular domain like CFX or Fluent or Polyflow Classic, or else on any structural transient or turbo machining fluid flow, it will automatically assign that the physics preference is according to your plan. So if it's electromagnetic module is choose it will reflect here, but here it automatically resumes that it's a uh, mechanical one. If we need it as a CFD one, we have to specify it in here. So if it's not specified here, it will affect the simulation and some type of mesh error will be there. So some unknown error will be happen while doing the solution CFX or any fluent simulation. So that's the thing. So here I'm not going to specify it. We are not going to any solving anything for today. So I'm not going to do any change here. So the next one is program the element thing. You can choose like program controlled linear or quadratic. So each also have option. Um, this must going to affect the simulation. So most of the problem we don't even think of that changing that to linear or quadratic thing. We just focus on program control only. Whenever the linear is comes into play, much more concentration should be there for selecting each and every option. So I'm going to specify it as program control. Then the thing is we can uh, have some sizing. So here we can specify each and every phase or any solid individually, or else you can keep totally here as well, and you can see that transition. And if it's a slow transition needed, the annealing and quenching. So what's the difference between that is the effect of a fluid or temperature difference immediately, or else it's on a uh, slow manner. So that's the difference here as well. So it will be like our formation of a mesh will be in a cold manner, or else it won't be a faster manner. So you can choose that. And here you can see some additional thing like surface area, and you can go through these specifications here. So here the span, like you can give like the fine, core, coarse, or medium. So the problem defines so what it should be like to be. And then here onwards you can see the quality. So if we want to have some quality like errors, and you can use some errors. If you don't want to look on the quality, you can choose accordingly. So if we need it as a quality worksheet, it will provide it here as well. So additional worksheet will be here. So if we need errors and should be warned by themselves, you can select that. So that's it. If we need the target mesh quality, you can specify that here. Or else you don't need it, you can specify that as well. I will explain that after. So the other thing is inflation. So you guys know about what a y plus value is. So y plus value is the distance from the boundary. So one of the boundary here. So I'm taking it as a boundary to an adjacent cell. So there will be cells, right? So the distance from the number of layers that should be there between the boundary to the center of the cell, the adjacent cell. So whenever we considering a problem like um, viscous problems or viscous boundary layer problem, like the center of the this is like a fluid region, not like a fluid region. It's a fluid region, like it's a pipe flow. This whole thing is a fluid region. So you know that at the center it will be a maximum velocity at the center, and from the center to the boundary the velocity changes. The velocity changes from zero, maximum to zero. So you know that this layer should have a value. The velocity will be zero in this layer, and the next layer it having some more velocity than the previous one, like zero, or will be like 0.1 or like that. So the comparison will be there. So if we mesh, if we not even bother about these particular area in this area. So these areas are going to have a crucial role whenever we go doing a viscous flow. So so that type of problem, like boundary level problem or boundary flow problem or viscous level problem, we have to mention the inflation. So the inflation layer will be formed inside of this area. So I'm going to explain that here. We can have this some inflation layer. So for that, we can give uh, how much layer it should be there. Like if we need a much more concentration into the layer here, and much more layers needed, much more concentration should be done on the viscous velocity. If it's not, if it will be give with a one or two layer, it will be like our meshing is not going to be smooth. We get a result, but we don't get a accurate result on this particular area. So you know that the mesh generation or the thing happened, um, like mesh generation or thing happened like uh, if we consider these are measures, so each mesh, each of the things, each entity is going to be have this equation, and this equation going to be corrected with some metrics. You know that um, the metrics of linear expansion or any linear metrics will be there. The matrix is calculated with this certain area. Then after this result, it goes to here. If it's we considering this as an entity, like uh, this is the model we created, and the mesh is only 3. So if it's a temperature here, and we are adding a temperature here, like 100 degrees Celsius, and here we are adding some other temperature, like 50 degrees Celsius as wall temperature, and 50 degrees Celsius, and 100 here, and 50 here, and we have to consider to go with the simulation. And when we consider only 3 measures available here, and you can see with 100 and 50 here, 50 here, and so you guys did some hand calculation. You can do with the hand calculation itself. Firstly, we have to do the simulation here with the Taylor series and things, and then after this result, there will be an temperature out from here. From the out temperature, we can calculate this, and then the out we can calculate this. So there's only certain points or certain volumes we considered. So the result will be not much accurate or not much thing will be here. But if it's like we're going to do a new one, so if we're going to consider a new as a new geometry here, and we going to have some more meshes, and so there will be some more calculation will be there. So the distance arises and the things, and you can see so many equations will be so much equation. So if we repaint the mesh with a finer, so it will be great result will be there. Some accuracy will be there. On there, we can see the temperature is 100, and we will get a answer like after mixing with the 50 degrees Celsius. and 50 degrees Celsius here, and after 100 and 100, so you'll get some value here, but it's not going to be an accurate value, not going to be an accurate value. But here we're going to have some more measures here. So each of the mesh having some result, and after that it's transferred to here, and transferred to here as well. So there will be some measures. So so many calculations can be done. So retaining this means a much more accurate result. So you guys know that retaining the mesh, it will also affect the computational cost of it. So but that for considering something like 10 or 1 meter cube. So we're going to have a simulation there. So we give this as a 0.1 mm as a refinement bed there. It will take much more longer time for finishing the machine. After the machine, you know that it will gonna affect the calculation as well. On the whole, the problem is going to be affected, the computational time, the result, and the accuracy of the problem. The whole thing will be affected by the second step. It will be affected by the geometry as well. So, and as well as that one of the important parameter or one of the important step is the meshing. So if you're going to give some final mesh, we don't know how the mesh is, and you're giving this as a final mesh, it will take some more time. But the thing you should understand, so how to find or how to give and and how to find an optimum mesh size. It's like giving an advice, not giving an advice. It's like we can be an expert in we can be an expert in measuring or fluent simulation or computed fluid dynamics or any simulation within a day. It's like a continuous practicing. So if we consider a simple geometry here and we consider something on any other geometry, the mesh size will be changed, and our perspective will be changed. Our point should be changed. You should have to be changed. I'm not saying that it should be changing. You should be changed for each problem in the simulation or each problem in the real-time simulation. The process should be changed. So you have to be focused on what to be done. So if it's like our problem is only discussing about the flow only, so the velocity only, we don't have to consider any external parameter, like if the pipe is going to be affected, like a pipe having a temperature of 50 degrees Celsius, we are not going to aware, or we are not going to consider that pipe diameter or pipe thickness or pipe material. So that's going to be affect the simulation. So the pipe density or the pipe properties. We in this model we are not considering the pipe properties. So you can see only two regions here. So if the problem is not going to be done with that thing, we don't have to be refine this area. If our consideration is much on the energy transfer between these areas, if a pipe is laid, like already someone posted in the group that they need conjugate heat transfer. The conjugate heat transfer is a transfer between the fluid to solid region. So if that's not going to be considered here, we don't need much refiner mesh or much important mesh here. So you can consider it as okay. We can go with without the inflation or without the further more clarification or further more refining. So you can stop there and can have some simple mesh, and you can go into relative or relatively more important mesh there. So it's according to your problem to choose any option. So if I am going to do a inflation here, you don't have to do on any simulation with the inflation. If it's not like a boundary layer problem with that, it's like an additional course for a computational course. So so how to reduce this computational cost is by mesh independent study. So that's a time consuming process. So we're giving some measures here with we should have to understood about this. Uh, mm, the mesh size we choosing here, you can see in the sizing we give some values here, the curves and the boundary book triangular. So it's give some values, minimum length and things like this. So if you are not going to So consider this as the first mesh region, and we create a mesh and solve this simulation. And then what is independent mesh independent study is we going to refine furthermore. If it's we choose here as a 5 mm as the mesh size, and we next step we are going to do with a 3 mm mesh size. So and then we're going to do the simulation and comparing the result. So there will be some difference will be there. If we consider temperature as outlet, and we consider giving it as a problem with 100 degrees Celsius here and 50 degrees Celsius here. So we get a temperature like 75 degrees Celsius here. Just consider it as. So after doing this first mesh, it giving 75 degrees Celsius. But then we refine the mesh with four 4 as the sizing, 4 mm as the sizing, then we get some result like 73 or 72 thing. So you can see there's a change in the temperature or change in the result. So then the next step is we can refine furthermore. I'm going to refine it with the 3 mm or 2 mm. I'm going to stepping into a wider guess, and I'm giving this as 2 mm. Then we got getting back into the solution, and the same setup. I'm not saying anything to be changed. The only thing changed is the mesh size. So we consider it as a change in the mesh, and we can so then one result is get got from our side. So that will be a value like I'm giving it as a 71 degree Celsius. So you can see that there's a temperature difference. So the result will change. So so the mesh is a problem. So the mesh is an optimum one right now. So we are going to do another one, another guess with I'm giving this values or 2 mm or 2 mm to 1 mm. So here we can after getting after completing the simulation, it gives around 71 degrees Celsius. Then you can see the chart is like this, and you can have this. Like if we consider it as a graph that of each measure, and I'm going to give this as 5, 4, 3, 2, 1, or else you can say that I'm just explaining. So the temperature is like 75 and 74, 73, 72, 71, and 70. So here it is like a 75, and here it changes, but comes into here and refining much more refining is happening. So up to a point, you can see if we change that to 0.5 or zero point 0.4 or zero point 0.1, the temperature result is not going to be changed. If it's sometimes it's going to be the problem with your solution setup, or else if the solution setup is all clear, so the temperature is not going to change. That means that's a machine dependent studies. You done the machine dependent study, and you can finalize that when the temperature or the result is going to be constant with comparing with the two independent mesh region, uh, or zero point 0.5 and zero point 0.4. With this, you can see the temperature is not going to be changed, or the result is not going to be changed. So then you can see that if we consider 1 mm, it takes some time for the simulation. The mesh refining is done. So sometimes like it generally takes saying it as 10 minutes. But the simulation time taken for the point 5 is like 15 minutes. And point 4, I'm going to give as 80 minutes. So you can compare this result. Well, if we give him much more finer mesh, the result is same, but the time is much costlier. This is the thing for a simple simulation. But if we consider we doing a simulation, or we consider some industrial level problem like big geometries out there, we can have it will be like simulation is going to be run with 2 or 3 days of simulation. If it's that much of core is used for the meshing or the high-end PCs out there, so high performance computers are used to inside. It will take as well as this much of days for the simulation. So the optimum thing or the optimal sizing for using a mesh should be done with we can say that it will be like uh, say that this one I'm going to be an exact one. It's only be done with machine dependent study and the quality. So the next factor we're going to consider is about the quality of the mesh. So some certain qualities when we are considering about the computational fluid dynamics, something is skewness, aspect ratio, and orthogonal quality. These are the three major quality parameters using in meshing to adapt and to know about what the thing is, or how this geometry is, and how this geometry is it okay for our simulation. It's just a study only. So sometimes a coarser mesh going to give some get value good values as well. But so these two constructions should be there. The one you can do with that mesh quality, and another one is the mesh independence. So with these both, we can say that our mesh is an optimum one. So these are the two factors. So any other factors will be like if it's like is this time it's like an A time. So you can upload your geometry in some of the A's, and you can say that A, that you can ask that A which is the sizing we should need. So you give me some specification like this is the geometry, so these are the templates, and this is the problem. It will give some value. But the greatest way is to understand is like these two factors or these two methods. And you can be an expert like this. So you have to be consider, you have to be experience it, you have to do some furthermore simulation and practicing it. Without practicing, it does not going to have some effect on your simulation. So after this, that's about the total overview about the meshing and how to do the meshing. So here, whenever we consider a geometry inside a mesh, so here we consider geometry, and you can see the geometry is important with its name and things. So if it's like any materials added, so like on structural part, you can add the material as well as here. But in the fluent or any other mechanical, you don't have to specify the material. If I'm about I have done some material property here or added some material here, you can have the material here as well. So you can see the coordinate system as well as you can change that if it's needed. After importing this geometry, the first step is to do uh, an an optimum mesh without changing any factors here. You should have to just right click and generate a mesh with the what the factor they said. So what the factor answers giving. So why this step I'm doing? If there's any flaws in the geometry, it will be understood. So we are the one we going to do geometry. Some manner will be there, some voids will be there, some discontinuity will be there. So we don't know that is the geometry is good or bad. So we can know about more about this geometry while doing this particular machine with a particular size they provided. After it's giving a green tick mark, we can see the geometry is fine, and we can step into measures. So in other steps, in anywhere you're going to face any issues in the next step, it will be about not about the geometry. It will be about the option you choose on this throughout this whole flow of machine. So it's a geometry is fine right now. So you can see the tick mark is here with the available machine. So the next one. The next one. So you can see the machine like this. So if it's like we need inflation. So if it's need an inflation, like I'm thoroughly giving an inflation like program control, and you can see the layers. I'm going to give this as a layer. And what is growth rate? Growth rate is like so that's an important parameter here as well. So you can see somewhere here. Growth rate is like the factor. If we consider like our growth rate from an inflation, so inflation layers will be produced on the wall is specified. After that, it's like we giving a 1.2 as a growth rate. It will like first of all they will give some measures here, and then it will be like we can give a value with respect to point 0 or 1 to um, 1 to 2 or 3. That's are the factors available. So you can choose with 1.2, 1.3 or anything else. So you can if if our consideration only on this area, we are not going to consider these particular area. We need coarse measure. We need not much consideration here. So we can give much more higher factor. If we give in some factors 1.6 or 1.7, it will like the next step will be like this, and next mesh generation or the mesh elements will be like this, and other one will be much more higher. So it's a factor that's going to be affected. So here you can see some inflation layer will be there. So here coming from the much more higher level to here, you can see the measures will be much more higher from this side. So it's a factor that the growth factor is going to affect the simulation or the software, the machine. So if we give some values of 1.1, you can see it will be much more finer here, but it will be like our graph will be like this, and if it's like if it's like 1.2 or 2 like this, our graph will be like this. So the rise in here will be an exponential. So the factor is increasing. The next step will be like this. So that's about the growth rate. So if we consider, if we want, you can have 1.05, and I will compare this result here. So that's the thing. So I'm going to generate this mesh. See any manipulation here, right? Or not. It's not made like that because we don't even given sizes. So we can add the meshing with some more inflation. We can add with other options as well. So I'm going to end this meshing here. So the next thing we can do is like add meshing with selecting this area. Here you can see some options. You can select with vertex option, or else with a face sizing, edge sizing, and body sizing can be done with each selection. You can do the meshing by clicking here and insert a sizing method. Like if you need sizing, you can click on sizing. Or if you need the face meshing, you can click here. Or if you need the inflation, you can click that as well. So I'm going to have sizing. So then we can see a side window appeared here. So here you can do the geometry selection like by name selection, or else can be done with our geometry selection as well. Sizing can be changed. If I'm going to select it as a with name selection, I'm going to select it as cold inlet. You can see it's changed that way face size. If I'm going to change the geometry selection and I'm going to click here and applying this, you can see that change it to body size. So the change is like if it's a face is going to be described, it will be automatically change that to face sizing. If it's like a body is going to be selected, so it will be renamed that body sizing. So here that's it. So the one option is like right clicking and inserting the sizing here. The another one is like I'm going to delete this one. The other one is like if you need something like I have to do a machine here. So I'm just clicking on here and here, then clicking on this particular area, and I am then inserting this sizing method. So then also allows you can see the face saving. So these are the options outlined here, or else you can click here and do some sizing options here. So many options here. Either way, any other way, you can choose this meshing, and all are same. So that's about pricing method. So here we can see these options are available because if this is a simple problem and we can select these data. If it's not being selected or not been chosen by our side, it will be much complicated. Like if geometry inside of a particular geometry, like and if our problem is like yeah, like an IC engine. So some valves have to be we have to mesh. We have to mesh that valve or any inside diameter or things like that. So for that, if you specify that on the naming, so if we have the naming, you can see the namings out here will be like what we give on here. If it's not out here, you can use that. So that will be considered. If it's a bigger problem like so many names out there, you can choose a name selection, or else you can click on this area and have the geometry. So I'm going to have geometry selection, and I'm going to give a mm, so you can see the my body sizing is given. Here you can add the element size. So the thing is, if I'm giving the automatic value is like 11 mm, and our thing is like 100 mm length and 30 mm diameter things here. So for that, I'm going to keep it as a 2 or 3 mm like sizing. I'm going it as a give it as a 3 mm. So and then I'm going to create and generate this mesh. You can see a final mesh is produced. It's it okay for a simulation. So you can see some meshes here and things like this. And then we can add some more meshes if I need some more refining on this area. So for that, I'm going to add this face sizing, and then I'm going to create a sizing with face sizing, and I'm giving this as a much more lower value. I'm going to give this 1 hour. You can see, and I'm going to generate this. You can see much more finer here comparing with these results. So for that, if you need to understand more about here, you can click on this. You can click on this section plane, and I'm going to create a section plane like this. Just having a section plane like this. Then you can see the section plane like here. You can see much more refined measures here, and comparing to here, you can see much more kind of refining measures. And comparing to any other phases, you can do some phase meshing. If it's a lab that's going to be affect your simulation, like the temperature input or temperature outlet is taken from this concentrated level, you can choose that area. Or like you can give phase meshing. Or if it's a boundary layer problem or boundary inside problem, or the whole consideration is about boundary only, you can choose that. Here I'm going to delete this, and you can see the mesh here. So if you need, you can refine this mesh. The second thing I'm going to do is I'm going to add impression layer. So if we add the impression layer, there will be some options will be there. So scoping method. So first thing we need to select which one, which area or which domain we're going to do an impression layer. So I'm going to click here. Automatically it provide like this. If we not provided, you can click on here, and I just give an apply and do boundary. So boundary, for that boundary I'm going to apply on this area, and I'm going to give this apply, and we can give this growth rate of 1.5, and I'm going to give this of 2, and we can compare the result. I'm going to give this 10, and click on here and generate this mesh. You can see the automatic generation of the inflation. We created some inflation on the sizing method, so it is ignored because we specified new inflation here. That's the thing. That's the message we got here. So no problem. That's just a warning only. So I think how to be changed something. Suppose I'm going to change this to here and applying it, and geometry I'm going to click here and click here. So here this is the inflection we needed here, so that's why. So here we can use generate mesh. So I'm going to delete this one and adding thing and getting back into this inflation. Reduce that. I'm going to create a inflation here with and delete. We'll get back to here. I'll get back to you. No problem here. I'm just create this generate mesh. So I'll give those information after the break. So the inflation can be done. So if it's not done here, we can I'll explain that. If any problem, I will look on that and get back to you. So the thing is like and other things like so if it's like a refinement needed or face meshing needed, you can add the face meshing as well. So that type of thing you can done. If it's like if something like if it's like face meshing is to be considered in your simulation, it should have to be uh, sometimes it's going to be affect the local meshing as well. If the local meshing is so fine, you don't need the face meshing as well. So if you consider face meshing, um, so face meshing here, it will affect. So I'm going here, and if we don't have to give any values here, if it's a well measured one, and it's not gonna be worked, or the face meshing not gonna be affected. So So face matching is whenever it's needed only, so it automatically streams that to be face matching that um, some is going to be it is suppressed by ourselves. And if it's like some problems, I need the space machine. Some of the thing automatically is out like here. So what I'm trying to say is, I'm deleting this one as well. So we can use the face machine or the face sizing directly. Face matching is whenever needed. You can say so it's mostly useful on particular measures. So that's it here. And in sizing, I'm going to add some more thing. So in here you can see the only thing is element size you created. If we have it's a like it's a circular entity, so you can say you can use a sphere of influence as well. If it's like it's a rectangular one, a rectangular block is used here, you can we have other options as well. And I'm going to explain that on no mesh. So with this simple mesh, you can see some more thing like I want to discuss that the skewness is a factor. So it should be a value that would be a much more relay on the value to zero. So what is skewness is if it's like if it's like it's this is a consider this as a mesh element. So if it's an equilateral triangle or a perfect length here or a perfect uh, uh, view here or a perfect sides here, you can see that it having a means value of zero. So if it's considering as a circle, it gives a value of zero. For a skewness factor zero means it much more good mesh. And if it's like considering it as a triangle and like this, so it we can see that the value is like around a 0.92 or thing. So it's now you can see that it's not an optimum triangle or not a great triangle or great equilateral triangle. There's some difference between an original triangle to this triangle. So the you can see with these factors that you can see if we, this one is if this one is good or this one or else this one is good. So the for the thing of that simulation and accuracy, we always choose with that perfect aligned geometry like this or meshing. So the thing like so our factor should be in the value most time should be in the value of lesser than 0.75. If it our geometry is much complicated or much of the thing is awaiting, so that type of thing or that type of value for that type of values, we can choose between a value of 0.85 or above. So it should be in a value should be in a term of uh, term in the range of 1. It should not be in the range of 1. For this a simple geometry, we should have a value between 0 to 0.75. So you can see you can experience much red value here. You can see here is a much more red value. So what we can see is we have to be give some inflation layers on there. So then we can consider it as a uh, it as an inflation layer should be there. So I'm going to add one more time the inflation layer. Yes, now the inflation is done and I'm going to get back into here. So you can see some inflation layer formed here. One problem here is like here, the geometry is like here. So it produces on here. It's reversely, we should have to be done with reversing. Um, Use my search file to ensure. So I'll explain that the mesh layer is like this, and the inflation layer will be changed like this. So that to be named like this. So delete this one. So that's about the quality of here. And I can explain that what happened after the shape. So here you can see our mesh is 10 with the one quality is skewness, and other quality we're going to explain is the aspect ratio. It will be in a value. You will see the minimum value should be in a range of lesser than 6. 6 as the so it won't be in a value in the range of 10 or above 8. It should be in a value, it should be lesser than 6 or 5 for the simulations. And the next thing we're going to do is orthogonal quality. Orthogonal quality will be available only if we select 50 here. So here you can see the orthogonal quality. So for CFD, it will be the qualities of things and be is changed to a number of things. You can see like that. And here also we can do one more time. Total quality is like should be in a value. Mostly should be in a value in the range of 1. I'm going to add one more time this inflation here. In the problem with here. What the problem here is created by the solid, I think. So that's the problem. Here. So one thing I'm going to do, going to close this one. I'm getting back into the geometry and I'm going to rename it as a fluid region. So it's automatically created like it's a solid region. That's why the inclusion is not going to work there. This one. And on the name selection, I'm going to give this as fluid region. Let's see what the problem is. So here, after this, so you can see this thing changed and asking for upstream data to need to be read. Click on OK. Check here. Same problem with this. We'll click on that and we'll get back into you. Um, so that's it about our thing here. Taking to this. After the break, I'll get back to you. No problem. So in the advanced option, you can see some more options here. If you need something like uh, number of CPU, you can do that. If it's needed much more concentrated mesh controlling or speed should be increased, um, you can use that CPU for parallel thing. And when I stepped out, so here the orthogonal quality, aspect ratio, skewness, and orthogonal aspect ratio, the element quality. These are the factors we're going to consider. And the other thing is like machine dependent study. So that's a whole thing about the meshing in the mechanical machine. So we can explore those things as well if it's needs some more phase spacing, phase scoping, or the match control or pinching or refinement you can turn on each of the operations. So this operation we can do that. And here as well. Um, So one more thing here, if in here, you see, we created some name selection, but for a industrial level problem, like a bigger problem, we created one more time, which I am going to create a new name selection, and I'm going to search a wall 2 or 2. So you can see some error will be occurred. So already wall 2 is inside of this wall, and you can see there's some issues arise. But it's a problem like we don't know. So many of them you specified, so many parts you specified, so many phases you specified, but you don't know if it's overlapped or not. For that, we can see in on clicking on the name selection and right clicking, and you can see one option repair overlapping name selection. So clicking on that, you can see it automatically grouped the new one which renamed recently will be added to the overlapping named region. You can see that the whole two is in here. So sometimes it's going to be a problem in your simulation. So two types of naming happen for a single entity or a single. So if it's overlapping the boundary condition or overlapping the name selections available there, there will be some problem arises when you're going to solve a problem. So that's it in the name selection. So we can see the errors will be like this. And we can simply delete this unwanted entity if it's don't need, and you can delete this or else you can add this as well if it's needed. You can if it's an important parameter that you have to be renamed with the two entities in a single one, and there should be a overlapping, you can choose that as well. So that's it here, and we can choose that sizing, and that's about the mechanical meshing here. And if you have any doubts, you can ask me up to here.
So then what is the usage of quadrilateral and triangular meshing?
Yeah, that's that's how it's going to be calculated. It's like if it's an if it's a quadrilateral thing, like the equation will be changed, and so this is an optimum. It's a triangular one. Is an optimum uh, size or method of machine sizing. If it's like a, rectangular region, like it's like a rectangular region is there, we can have this uh, triangular entity will be there, or triangular machine, or triangular elements will be there. If it's like a curved thing, or else anything like not a rectangular one, like on here, you can see some curves out there, or else undefined geometry, or if it's like a no, not like a normal geometry will be there. There will be it automatically. We don't have to look for this triangular one, we can choose with that quadrilateral one. So the equation will be changed and the equation calculation will be changed. So there will be some difference between them. So the most of the problem it goes with the triangular entity. So that's optimum one. Or else our geometry, according to our geometry, we can change that as well. If we need much more in the curved region or much more in any other uh, like unauthorized type of geometry is there, we can choose a quadrilateral. So there will be no difference between if it's quality is assuring, you can use both as well. If it's a triangular or else a quadrilateral. So the thing is, according to our geometry, we can change it. So if it's need much more concentration into a boundary or a curved region, you can choose the quadrilateral, or else you can go with the triangular. So sometimes it's going to be affect on the result if it's like not an optimum rectangle or the edge width size is there. So that's only difference.
Sir, in
Sir,
is
if
every
I
time
have
it required
Yeah,
to
yeah.
define our fluid region or solid region, or sometimes we simulate without selecting the fluid region, but it's give the result as much as possible to the fluid region.
I, I don't understand. Can you let me one more time?
Sir, it is necessary to bifurcate the fluid region and solid region in the
No
machine.
need. No need for that. But if you're getting into the simulation side, on the solver side, it will be automatically renamed like the fluent itself rename it as one region one or inside region or interior region or like that. So it will answer it will automatically renames or resembles like that. So if a bigger problem is out there, if it's a simple problem like this, only single entity here or a single region out here, we don't have to bother about renaming your things. So we can directly click on I will show it later. Uh, Connect with the fluent. If it go with that renaming and fluid region, it will there will be a certain path will be there. This is a professional way of doing is like that. If it's not you're not aware of things and we don't have to rename it, it will automatically shows like clicking on here and delete this naming and it will show you how it's gonna be like that. How difficult it is. So I'm going to delete this name selection here. So here, so if I delete in this name selection, so now we going to add this one after updating. When we going into the setup, here as well you can see there's no inlet, there's no outlet, and it automatically shares only geometry only. But we going into the boundary layer, you can see the thing is you can see if we note rename this region, it will say that the interior of solid. It automatically created it as a solid region. If you want, you can, if it's like a cell region, it's only a fluid region only. If you are going to simulate it as a solid region, you have to click on here and type to solid here. Okay, so if it's on the boundary condition, you can see only walls, and the only wall is here. So if I click on here and display it, you can see where this, no, it's not going to be seen by outside. So, so the thing is, if it's not be defined, it will affect the clarity of the simulation. If you don't know, it's like only it's only defined as a full region only. We don't have the inlet, we don't have the outlet or anything. Only thing is a fluid region. So if we do not even give this as a successfully give yourself a naming, it will affect the simulation. For the clarity of the simulation, let's be giving the naming of fluid region and solid. If it's so comes into a question that if we don't name it as a fluid or solid region, if some other entities like an enclosure or out there or a pipe structure out there, we have to define each of that region, right? If the pipe out there is be a wall, no, sorry, it should be a solid, and the enclosure should be a another fluid. So each of the thing have to be uh, uh, renamed or should have to be changed from outside. So it should have to be checked with if it's a solid region or fluid region from outside. And if it's a simple region, like one or two fluid region is out there, or one or two solid region out there, it's easier. But if it's come to a bigger problem or bigger canvas problem, like so many fluid regions and so many solid regions out there, so that's time it's going to be affect your simulation. So it will be confusion out there, no problem. You can simulate the solution. If you give an input, it will process and gives an output. But for the clarity of the simulation, for the accomplishment of the real world problem towards your problem, you should have to rename it properly. That's it. Any others?
Sir, yes,
Yeah,
sir. I have a
yeah,
question.
yeah.
In my case, I am using multiple layers. You know? So, is it necessary always to have the conformal mesh?
So conformal mesh is like so it's according to your problem. What's your problem statement, sir?
I have the multiple layers like composite walls case. So,
Okay.
I just want to check the heat transfer through the composite layer. Okay.
Okay, okay,
So,
okay.
so in that case, is it necessary to have the conformal mesh
Yes,
for this?
definitely. If it's
And if it is necessary, then what are the methods to have that conformal mesh?
so you should have to provide the shared topology first. The shared topology
Okay.
is not, yeah. So I think for
Like
your
yes,
simulation,
yes.
go with the, it's a fluid simulation, right? Fluid will be there. So where you going to do the simulation? It's on a static structure or else on a fluid simulation?
Any fluid.
Yeah, fluid. So for
Actually,
that simulation, I
after
will
that, these
suggest,
comp yes,
yeah, I
yes,
will
sir.
suggest you to go with that fluent meshing out there. I'm going to cover this area on the next session, not in the next session. After the break, I will cover that how to do a meshing on the fluent simulation, a fluent
Okay.
meshing. So that will be much more good for your thing. So there you can provide shared topology, and from while we giving the shared topology, it will be like a conformal mesh will automatically create on your region.
Okay.
Okay, shared topology is a factor. If it's not, you are not given the shared topology, you will get like different meshes on different area. Non-conformal mesh will be there.
Okay. If I'm creating geometry in the design modeler, and I am just combining all the three layers like in the single part, so that is the kind of shared topology, no only.
No.
Means
If we assembly these thing, it will be Ansys itself saying that it's a three different geometries and not having there will be some connection, but the mesh will be not be a conformal mesh.
Okay.
Okay, so you should have to provide the shared topology. So for that, we can do it on space claim, or else on if you want to then do the simulation or the meshing in mechanical meshing, you can do it space claim and edit that on the shared topology and apply the shared topology on the particular option. Then you
The
can do
shared
the
topology
mechanical.
option is not available in the design modeler.
No. I think
Okay.
it's no. No, I'm not aware about no so much about the same model. That's why.
So
Uh,
I'm creating, suppose I have created 3 different walls, and then I just create single part combining all 3 walls. So that create a single part, and so this is not a shared topology, no?
no. We have to provide that shared topology. So for that, if you have to do the meshing on fluent meshing, you don't have to do that on that space claim itself. You can directly do the meshing on fluent meshing. I think it will be good for you if it's if you model it on design model, you can do this meshing in fluent meshing, and you can complete the shared topology there, and you can proceed with your simulation.
Okay, sir.
Okay. So that's all. Good region, for example, they are battery and access keys and should be different for yeah. So for the fluid region, there should be a inflection layer. If it's like a heat transfer or velocity comes into play in your problem, should be an inflection layer should be there. So there it automatically produces some interfaces as well. So pretty good with. And for this region, the meshing should be defined differently. You can go with the conformal or non-conformal mesh. So if it's like a transfer thing, you can go with that conformal mesh, or it's like you don't have too much worry about that external factors. You can see with the non-conformal mesh as well. So it's very important to have inflation layer outside it. Okay. Any other doubts?
Excuse me, sir.
Yeah.
Sir, I am working in the research area of aerodynamics in vehicles. So here I am working on rotating wheels, sir. There I have some doubt on moving reference frame
Okay.
while using rotating tires. So I am getting continuous error while creating reference frames. Any idea about it?
That's the thing. So I have to look on that problem as well. So I have to look on that problem first. So how the problem is going to affect or how you done like that. So if you have your number, have my number, please text me and we can explain on there and explain your problem as well, and then we can go with that.
Okay, sir.
So we have to create the layer on PCM contact circle. So most of the time we create the layer on the fluid region, not on the solid region. So it's like PCM around it. So PCM is like an heat transfer method. Like so, the other one is a solid one. So we can create inclusion layer on there. It will be much impact when PCM is the contact surface PCM. Okay. Any other doubt? Okay then. So the next thing we going to discuss is about fluent meshing. So the other one of the other, one of the important one is fluent meshing. So what I'm trying to say is in fluent meshing. So in this mechanical meshing is more suitable for the structural thing, and most of the problems suitable with structural. So the whole structural thing or the FE analysis, it's like an advantage for a mechanical machine. But for in fluent simulation, most of the fluent simulation we can go with that fluent machine. So that's a wonderful area, and it's a much more not much complicated like this one. Like impression layer should be there. There will be much more problem will be there. You can look on there. So that's the thing we're going to do. Explain. I'm going to explain next thing. Next step as a next step. So, sir, hello, 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 sir, hello, Manu, sir. Are you able to? Okay, then I'm going to have a break and we can resume the session at 11:35, and so we can have a break up to 11:35 or 11:36. So,
Okay.
okay, okay. Hello. Hello everyone. I think I'm audible. So, so what we're going to do here right now, it's the comparison circuit for fluid machine and mechanical machine. So I'm going to have a PPT. I prepared PPT for that. So you can see that the workflow comparison with the Ansys mechanical machine and Ansys fluid machine. So it's mostly useful when the simulation type is like a structural, exploited dynamics, or electromagnetic. So it generated or it's, sorry. Okay, I think now the sharing is done. Okay, so here you can see the point. So you can see uh, and the Ansys mechanical machine is mostly useful when there is something like mostly it's generated for a simulation based on structural explicit dynamics, and mostly um, it's a physics one, and so it's a then for mostly for this type of simulation. But comes into fluent meshing, so it mostly useful when like a watertight geometry. Watertight geometry is not like there will be no gaps between anything like any geometry incorrection or like any geometry mismatch will be there. So for that type of geometry, we can choose that as watertight geometry, and also less about some fault tolerant machine like some imperfect CAD can be done here. So it's like a task-based one. So there will be a certain flow of simulation machine, certain flow steps will be there. So if you see on mechanical machine, you can see a perfect various steps out there. We can directly do the meshing, or we can name it firstly, or we can do something else as well. But when it comes to Ansys Fluent Machine, there will be this is a gated one. There will be a step by step cadence will be there. It's like a most advanced one. It's a Fluent meshing. So it's converted to the phased data and for the machine data, and it gives a manual control for mesh refinement and quality. So the next one is mesh generation. So mostly this pre and post inflation can be done, and generation of hex meshes, and we can control the quality through the tailoring of this controls or element size and quality throughout the simulation. It's mostly useful handle structural multi-physics problems. So some automations will be there, and measured out so automatically when the geometry changes. It also advantage of fluent meshing as well. So you can see that so many other type of meshes out there like tetrahedral, hex core, polyhedral, polyhex core. So it's mostly useful for whenever there's a fluent simulation like on watertight geometries. It's done with a high quality with the boundary layer mesh generation, while the um, you can choose other complex geometries as well. So it can be automated as well. So the rock refinement and data geometry features will be there. Some inflation problem will be there. So no problem. Then fluent simulation is more suitable to go with um, fluent meshing. The thing is, the next thing is about supported physics. It is mostly suitable for FE and experienced dynamics. And some sort of so we can choose a mechanical CFD or CFD simulation or CFX simulation as well as there. Also, you can in the fluent machine, it mostly suitable for the computational fluid dynamics applications like a CFX and ICM or anything like that. So the mostly the flow or the simulation like a battery, so it's a CHT transfer, or the it's like a complex geometries can be done with safety models can be done with fluent meshing. If it's a simple one, you can go with that mechanical meshing as well. Next thing, so typical application. So so you can see that is less using endless drainer, impact thruster, ultramagnetic simulation. So this type of simulation can be done. So for the computational simulations, like more rely on this type of different type of problem like turbulence and energy transfer is a major concern of multi-flow or fluid generation or fluid things or mixing of fluids. So those type of simulations, there's a fluid machine is applied. So that's it about our intro. So, so we can get into a simulation. So for that, first of all, I'm going to do create a fluent with fluent simulation, and I'm going to create the same geometry. It will save that yet, so I'm going to create the same geometry once again. Here onwards, I want you to create a geometry, and we can complete the and explore the options here. So in the previous session, I didn't go through that because you already know about the machine and machine things. So here it's a new one. So I want you to be prepare a geometry for the fluent machine. So for that, first of all, I'm going to extract already created. So here we had to rename it. So first of all, I'm going to name this as inlet. So these are the things I have done. So please do this and let me know so that we can go into the fluid machine. So that's it. Two cylinders and it's contacting each other, and we give this naming according to you. Two inlet will be there, one outlet, and give this naming it as whole, and give this fluid region, select the whole thing, and select it as whole region, and that's it. Please let me know after doing this geometry that we can get into fluent machine. Just let me know in the comments or in the group as well. After completing it. In the meantime, I'm going to create another geometry as well. Complete your geometry and I will give an answer geometry. So here I'm going to create three solids. So in here, identical cube I created. So here I'm going to prepare a these are values as 50, 50, 50, 50. I'm going to create this folder like this. So just go this one. This. So someone said that so while doing this enclosure method, you can see some cavity on there. So if it's not single side, you can do the section as well. In the section, you can see that the cavity out there. The cavity will be there while using the enclosure. It automatically creates the cavity as, and we don't have to do any a boolean thing. So okay, this is the geometry I given. I can choose anything. So just to compare the result, I have created three bodies and one enclosure around it. Okay, close this. Okay, I think that is finished the geometry. So we can step into mesh generation. And so here, while using the mesh conversion, it enables Fluent launcher because it's parallel to the Fluent. So the Fluent simulation, that's why the Fluent runner. So you can see the meshing processes and solver process as well. Here accordingly, for me, it's 4. And if it's your system is running so too slow, you can choose that as 2 or 1. So I'm going to give this as 4, and I'm clicking start. So this is a workflow, and you can see the first step. I already set it. There's some set of way for everything or setting step for thing. So first thing, we have to import the geometry. If it's not imported from outside, you can. Uh, if it's not done like this or any other thing, or you don't created geometry here, you can directly open meshing, and then you can import geometry by clicking on this three dot and give this file. So if it's already that gives this file location and the geometry already inside of that cell, that's why I can edit this. If it's created earlier, you can click that as well. So after using this, if it's like a multiple files is out there, you can choose that. Or and the units as well, you can change that. And after this, any other advanced option, you can use that wrap body or any separate zone by thing. You can choose that. I'm not choosing anything. I'm just going to import this. So our thing is like this. If it's a geometry, before we go into simulate, or if it's a, you can see it's a watertight geometry, it's automatically enabled like that. If it's not a watertight geometry, if it like any other geometry, it's not a watertight geometry, you can select that as well. But here it's a perfect model out there, and there's no dimensional inaccuracy or modeling inaccuracy. So that's why we can change that to anything else. And you can see here on the first option, so you can, after doing the meshing, you don't have to close this window. You can directly go to solutions from here. So that's an advantage here. And you can check the quality and performance check and perform diagnostic ceremony or quality, evaluate the surface quality here. And the other one is like insert the clipping plane, and we can add which one is needed. If it's on the X axis, Y axis, or on Z axis, we can choose that, and we can click on here to know about the thing. And you can zoom in or zoom out like thing, and if you want to add the face on or face on groups, you can if you want the code inlet only, you can display that only. And we want the hot inlet and outlet as well, as you can choose that, or else wall as well, you can see that as well. So that's it about here. And if it's like the nodes, boundaries, cells, you can use that, and the edges. And so that's it about here. You can export these things. If a lighting needle, color needle, you can choose these things. So that's about an overview about here. So the next step, we're going to create local sizing. So do we need local sizing or not? It's like sizing method we choosing on mechanical machine. So I'm going to say I needed the local sizing. So here, if you select a face, it will automatically select the face sizing because we are creating a solid or any body, so it will automatically be a body sizing. So here are some options out there like body sizing, face sizing out there. So if I'm going to click the body sizing, you can only see the fluid region only. You can see uh, this upward. You can see one fluid region only. We create that we don't have to select each of the things here. We can select our entity here or any phases here. If we renamed each and every object or each and every detail in the space claim itself, the named selection will be only be reflected here. So if I'm clicking on the face, I think you can see these type of faces we created or these type of faces out there. You can create on each of the faces. So if you can multiply select each of the thing, if you need these two, you can multiple select it with using control option. So here as well, the fluid region as well as here. If we need, if so many namings out there for that, we can use with this option on the search option. You can see. So with this search option by using the stars, if we specify something like any cold inlet, cold, we renamed some region, if a different region out there. So we with knowing the performance on this fluid machine, we know that we should have to specify some additional machine on some region. If it's like a motor, I'm saying that on so consider it as a motor, and we're going to do a fluid machine on a motor. So we have some rotating part. So for that, I just giving so every rotating part I am specified. I'm giving one thing, one on naming on that initial side or the first side of that naming as arrow, like a rotating like a specification. For arrow at arrow bearing, I need some machine. So if it's at a stationary bearing is out there, I just specify it as a STR bearing. So that type of a naming can be done. Naming adjustment can be done, and we can search here as well. So while choosing this option, we can search one name or one entity like that. We can group things like that. Or else here also you can see filter texture or any there's some trees out there sometimes. So here I'm going to have resizing. No, I'm going to give this a body size. So here you can provide the targeted body size here. So I just clear in the preview, and it's like on meter. So we can provide that on millimeter, or else you can change the unit here. I am going to I'm going to give 0.2 here, and while clicking on this blue region, you will see some preview will be there, and you can see the growth rate. I already discussed that the growth rate is the one thing after our meshing. What will be the next mesh will be? So that's about growth rate. I clicked here and add local sizing. So you can see the one body sizing is done. The another one, I'm going to click on here. And, this naming can be renamed. So here I'm going to have a face sizing of hot inlet and cold inlet, and I'm going to give 21, 0.0001, and I'm going to add it the face size 1. After this, we can create the generate bit. So this is like a um, surface. It's like a step-by-step method. So you can't jump into another step like on the final step like that. we have to do each and every step. For that, you can see our preview like this. You can see the preview. If you want to reduce this preview or reduce this one, our measures will be like this. So I'm going to give this as 0.1, and the maximum size I'm going to give this as 0.0. I'm going to give this as 0.05. You can see the preview change to much more low one. Or if it's changed that to be 0.5, as well as you can see it's changed. So accordingly you can change that and here as well. So I will change it. And if it's like a mesh maximum size, if you need, you can click on there. And growth rate, if I will compare the growth rate between three different region in the next meshing. So here I'm going to have an introduction only. So again, this is curvature and proximity. So there's a curvature and proximity out there. So you can choose. I will compare that as well if we have time. So it's like 180-degree of angle will be there. Like um, so if we see a circle and it only half the circle. And so considering that the half circle is 180-degree. If we providing 18 as the normal angle, you can see uh, in 180-degree, it's just 10 division will be there. So 180 by 18, 10 division will be there. So 10 will be divided by 10 here. If it we increase it like 10 degree as the curvature angle, it will be 18 points here. So if you reduce those angles, it will be reduced on here as well. So that's about curvature. Proximity is whenever come into consideration whenever there is a minute thing like our fin we created yesterday. So for that simulation or for that heat sink, so there's we needed the proximity only. There's no curvature out there. But here we need a curvature and proximity. If we need curvature only, we can choose that as well. And scope to edges and edges is out there. If we had time, we can compare those results here as well. So I'm not to explain this. So the scope proximity to edges, if it's needed, you can choose edges, or else you can choose the faces and edges. So after clicking on this, you can see take some time. So in the meantime, please text me if you have completed the uh, machine up to this point. Please let me know. Any challenges facing, please let me know in the comments. Yeah, yes, 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 it is. Not the common surface actually. There's a boundary or a layer is created. So there's a layer, solid layer, and a fluid layer will be there. So if we consider or generate simulation, there will be two layer on a single entity. Like, so consider it as it's a solar region, and this is the fluid region. So in between these two, there will be two region will be there. One is like one is a solid, one is a fluid solid region. Or whenever we considering fluid structure interaction, it's an interesting topic in simulation. So and the other one like, and for solid region it will be like another layer will be there. So two layer will be there, like other than solid. Between the solid there will be a other than the solid and fluid region or a fluid to solid region, and there will be a fluid solid interaction region. So there's an interface that fluid solid interactive interface will be there, and as well as a solid fluid interface will be automatically created. So whenever we creating and we explain or we just uh, we just give the instruction like there's a fluid and a solid region comes into contact. It automatically create an interference. So interface will be created, and there you can see the interface and mesh interface will be available on the mesh solving mesh answers fluent solver. So whenever a solid and fluid comes into contact, there will be something. Some interface will be generated with the solid as one thing, and two interface will be there: solid fluid and fluid solid. Two interfaces will be there. If we need the conformal mesh, like already said that if the conformal mesh needed, it will be a continuous thing like this, and it's like a continuous thing like this. A continuous mesh will be there is no need for boundary generation, and our the whole machine will be like this, and there is no boundary does not define the ending of the machine. If it's a conformal mesh, if it's not a conformal mesh, it will be like it will be like I'm going to create one. So if we don't give the shared topology, it will be like there's an end here, and after that there will be no meshes. And this is about conformal and non-conformal mesh. So there will be an end here. That's a thing. That's a thing. That's the difference between conformal and non-conformal mesh. So it will be like this. It's not a. So whenever there is an interface, we have to go with the conformal mesh whenever it's needed. So that's right. We have the concept to understand what is a fluid solid interface and fluid solid interface whenever we're doing a coupling of fluid solid interaction or CHT type of simulation. Then right now you can see machine. see right now. Okay. After that, you can see we can describe this geometry. If it's only a solid region, we can click on solid region. If it's only a fluid region with no voids, we can click there. So here it's only a fluid region. And after clicking that, you see something is goes away, something gone away. So if it's like a fluid and solid region, you can see the shade topology appeared and some other options appeared. Multi-zone meshing is needed. You can see that as well. And shade topology, if you need shade topology, you can click here. And after that, it will automatically create the interface between two regions. So for our problem, we don't need shade topology. It's only fluid without any voids out here. So I'm just describing this geometry. And here we can specify the inlet. If you don't want, we can skip that as well. We can do this type of thing on Fluent simulation and Fluent solver, and don't have to bother about things. If we suggest one thing like we giving it as an wall or inlet or anything, you can give it here. We can change that on the Fluent solver as well. So no need to worry. Just ignore this one. If you change this here as well, it will be changed around Fluent solver as well. So nothing to worry here. I'm just updating this boundary. And the next thing they're saying about this is a fluid or solid region, and I can create saying that if multiple zones are there, we can say that there's a fluid and there's a solid region. So here I'm going to create this as a fluid region. So after that, I can update. So then it's saying that any type of boundary layers needed. If it's like if you don't want this, you can click on no. If it's like for another boundary layer, the smooth transition needed or aspect ratio or things like that you can have this, or else on right clicking on this, you can create a geometry surfaces. You can uh, yeah, I will import that and here. By clicking on here, we can add the value like improve the surface mesh. I already mentioned the importance of skewness in a meshing entity. So for that, we can improve the surface mesh, improve the meshing by clicking here, and we can give a value. If we need a skewness less than 0.7, we can add that as well. Or your geometry is much more complicated, you can create that to 0.8 or thing. So if you need that, you can give. And I'm going to give this as improve surface mesh here, adding 0.7 here. And then after that, so surface mesh is improved. Here is the one, three, what's the number of layers? This number of layers that we made some like uh, face sizing, body sizing is given. It's a number of layers should be between two boundaries. If it I am saying that as a three boundary, it's like we will see three mesh region or three layer will be here. If you want more, we can create that to 5 or 8 according to your specification. So that and if it's like we can name it to name region or fluid region. So nothing to do here. We can specify that its a growth should be on walls or else on any area or a fluid solid interface mentioned here. If you want the fluid solid interfaces, you can specify on there, and the growth rate as well. If you change the growth rate, it will be affect the whole number of elements as well. So after this, I am clicking this add boundary layer. So the inflation control added, and you can see if we give some more number of layers, it will be up the inflation as well. And the last one, I'm going to create generating the volume mesh. Here you can specify the solver. If you want to be done in CFX, the solver you can change here. If you don't want, you can specify it as fluent only. So here you can see polyhedra, polyhexcore, hexcore, tetrahedral. So these are we choose according to the problem. If it's a boundary layer problem, we can more suitable uh, for polyhexcore. If it's like it's an advantage between it's a pros, it's a combination of pros of hexcore and polyhedra. So it's a much more good for polyhexcore. Tetrahedral, whenever it's come to a simulation of turbulence or turbulent intensity type of problem, we can choose tetrahedral. For here, you can choose according to your problem. So now I'm going to use this as a polyhedra here, and then you can compare those results. It will take some time. In the meantime, any doubts, you can shoot it. If any problem or creating up to this point, any other, just let me know in the comments.
Sir, then what is the difference between the one meshing we have done separately on mesh section and in Fluent with meshing? Is
So
there
it's not
any difference between them?
much difference is there. There's a certain flow is there. So this is more accurate or much more simpler for coming into machine. If you don't have much more expertise in machine, you can simply do the fluent machine. So that's the main advantage of doing fluent machine. If you have much more experience in all the machine, so you don't have to do this type of typical machine out here. So here it's much more user friendly, and you can explore. You can there's a certain flow is there. So you saw one thing like while I'm doing the inflation on the certain inflation on a particular area, I just checked and some error happened. But here, if we give the same value or give the same instruction here, if there's a continuous flow will be there, you will get a result. But there you need to go back into the error and get back into result, and should know where the problem arises, where the thing arises. But here, there's a certain flow will be there, so you don't have to worry about if it's a problem arises on the this step, you will be stopped on that step, and you don't have to worry about the previous steps you followed. You just have to get on this particular area. Okay, if it's not the tick mark is there, that will be good. You can easily understand where the
Sir,
problem is. Yeah.
sir, how we give fluid or air medium inside the structure?
Here you can add this fluid or air medium. If it's a fluid, you can add just fluid only. In the solver preference, you can add the material.
And sir, where should we add?
In the
In
solver.
boundary condition, it is in boundary condition. It is not showing na in my structure. In my structure is
No,
greenhouse.
no, not in the boundary condition. There's a option for cell zone condition there. There you can add the material.
Which condition, sir? Which condition?
Cell zone condition, cell zone condition.
Cell zone condition. Okay.
Yeah, cell zone condition. On there you can add the properties of solid material or solid
Okay.
solid one, fluid one. You can
Okay.
change the material there.
Okay. Okay. ठीक है.
Take this much time. So any other doubts, please let me know. Some doubts in here. Okay. So please have any doubts here? In the meantime, I will play one PPT.
No, sure.
Okay. In the meantime, I will explain one PPT here. So, just checking not an issue. So this thing has happened because we reduced the purpose mesh and reduce the value there. So it's take this much of time for this maximum length we given like a 0.05. That's the problem. So please listen. So I'm going to have a PPT here. So it's about fluent machine. So it's an updated one. So how to improve the channel improvement in the fluent machine. So the thing is, you can choose this. Already explained that you can choose this inflation or the machine with the clipping plane. So by placing the two options, you can do this clipping plane either ways. So if it's like you want to improve the graphic performance on the preferences, you can improve our uh, optimize the input data by using the enable options. These are additional options for doing a smooth interface for you. And these are the quality improvement. So you can see the difference in that type of this type of simulation that global improvement, the global editing mesh. With the global editing mesh, you can see the difference here. So it's much more finer. So comparing with these, we can improve these things global poly mesh quality improvement. And the next one, you can use it auto mesh, and it's been used in Solo itself. You can have these equations and create thin volume controls. You can directly do a watertight geometry with the watertight meshing on the solver itself, adding some additional features like this. So it's about the watertight flow, and you can have a range of products will be there. So sometimes will be thin volume, sometimes there will be multi-zone will be there. So you can easily activate each of the thing for a watertight geometry. And so you can select each of the thing like this. You can see and you know about that. If it's a non-conformal body, so the you can change that simulation time. If it's well, larger amount of entities are out there, we specify each of the things can be reduced the time. So the volume mesh from the import the volume mesh, it will much more similar one in the water tight geometry. That's only the thing we can understood from this thing. So the last one, and the local refine is the region. So there's some options out there for vector and line, and so that's a two position method. You can choose either the vector and length method, or else you can go with the two position like a radius 1 and radius 2. So it's available in the FTM, and that's a thing you can do with the filter and vector and length. And you can see the methods, with the methods. You can refine the regions using the cylinder or cluster. Other one is create spaces, and there's a comparison of and in advanced options you can see it creates spheres like it will create something like this. If it's like a smooth faces we needed, and there's a new updation you can see in the 2024 R2. So you can create this as a smooth face that it will generate a mesh like this. And so comparative study of this the setup like creating spheres and better quality, the minimum output quality will be increased, and while choosing the creating sphere, it's a comparative study of the previous software and the new software. So, okay. So the pool based sizing for solvers. So it's we can choose polyhex curve and fill in solids with the polyhedra and hex core for the full region. So that's the idea behind this polyhex core one. Um, polyfill will be used in the solids for the growth, and um, it's a vast one. It can be in to city, we can choose the angle difference between each of them. You can see that one thing I mentioned in the that curvature and proximity like that. There's a periodicity is another factor. With that, you can see the angle differences, angle changes, how is the angle going to be, and with the snake selection, how this going to be changed with the period multiple periodicity definition. And it's like the improving method. So to reduce this time method, so or else you can see that so many additional things can be done on this fluid machine other than the mechanic one. That's a uh, primary thing. So you can have so many importance and so many specified or specialized machine can be done on this machine. This one module like Fluent Solver, you should have to be aware about the settings well in this area. If we continue the class, we will be get stuck on somewhere. So in the meantime, we'll get back into our Fluent. Let's see. I think. Mhm. So this was the last step in this generation. You can choose the polyhedra, tetrahedral, or polyhex for here. So I think it takes much more time, longer than usual. So, so this is the thermal formation of going from fluid machine. Uh, it's like additional settings will be there, like I'm going to cancel this one. Cancel this one. Mm. In this task, and we get back in workbench, and so I'm going back to the mapping. I'm changing this value to higher one to know about how this machine will be. So not the problem is if you don't have a higher performance computer, it will be structural, it will time taking one. And the advantage of it is there will be flow, the error identification is much more similar here. So that's it. Can explore these things. You can see that here you can, if you want a 2D machine, you can create here. That's one. If you want the alternate geometry, you can use this as well. So click here and you can choose accordingly. And here I'm going to import the geometry. I'm going to add much more here. So here I'm going to add the body facing only. So let me value percent was around. Add this region. We can use that 145. To give this 0.02. Separate it one more higher. Okay. Okay, this is fine. And I'm the developer mesh. Yeah, I got disconnected. Can you close it again? The formatting version time should be set up. Yeah, sometimes it's gonna be not much will be there if you create like we give similar thing or much more final mesh or specify each of the thing. There's really not much problem with the mesh. It will be easier. So refining this mesh gives much more time consuming. That's the problem. We don't share topology as we cannot skip this step. So if it's a shared topology is one thing we use whenever we need the conformal or non-conformal mesh. So choose wisely whenever we need it. And the shared topology is not going to be affect the whole meshing time or complex features or things. So we can do that shared topology. That will be so. It's about how you give the value of that sizing method and body sizing. You can see the skewness of the phone 3 here and the surface meshing. So you can see the value here. That's a good mesh. So then you can see if you need any boundary wall to internal and just drawing it is the same geometry. Geometry, taking this up to. And with a fill, I'm going to have this as a value. Last one, I'm going to create this polling at the you can better control understood the solid as well. So you see why we give it this three layer of poly meshes surface meshes here that you can see the three layer and the gap between that three meshes three only we gave it as three cells per gap. So it's arranged like this. You can see three cells, 1, 2, 3 only. So that's it about creating this mesh. So this is also a good mesh. So if you want to refine it, we can refine with these all values like smooth and if you remove and edit and just giving the layer. If I give the sixth layer and updating it, and then we have four. No. You can see much more finer mesh and the difference between that holy hex core and here you can see the holy hex core here and it's a much more refined one and you can see the layers added here, 6 layers added here like inflation layer. So much error reduced here. If we have any error, we can easily change here and I'm going to revert and edit and I'm going to add 6 layers and on the general surface I'm going to have a hex core here and you can see what it will be. So here there's some more, it's like a triangular or rectangular thing happened here and much more like structured meshes here and not much volumes here. So if it's like a problem to be like this, so some disadvantages for this problem is like you can see non-uniformity here. So something is lower in here, something is higher in here. If it's edit here, I'm going to change that to tetrahedral. What will be, and I'm going to change that it here and I can showcase you uh, how the growth rate going to affect the simulation or the machine. We can see thing like this. So this is about tetrahedral. So you can see it's a much more good one and evenly spread like this. You want to edit that, so to change that growth rate to 1.1. So there will be some effect. So there's some more effect is there. So the growth rate, like you can see from here to center, the length and the size is changing. So that is about the growth rate. If you want that smooth transition, you can change that as well here. So this much about here. There is so much thing to concern in the volumetric, the fluid machine can add ints and everything. So many additional steps there. So you can explore those on Ansys innovation courses or in there's so many there's a free source like Ansys innovation courses or else while clicking on here you can directly go to the help option also on Ansys Workbench help. It will automatically goes to enable a new window out here. So in the helping portal, you can see so many free resources available here. You can explore each and everything. Like if I click on this home option, you can see some options here for Fluent. So for Fluent, you can see so many tutorials out there, out here, so many videos out here, and documentations out here. So you can explore those things. If you want something new, like you know about the fluid machine, you can access from here as a free of course. I'm just giving those things here. And so here we can see fluid machine mode. So many things are out here. So you can explore these things. So and within a one day you can be an expert in fluid machine. I try to convey myself what I can give you in this short span of time. If you want, you can explore through these type of additional resources. So Ansys Innovation Course is an additional other one. So Ansys Innovation Coach is a free platform. You can explore that as well. So that courses and Ansys Innovation courses. So that in free courses you can see if it's like a structure, you can see you need only fluids, it will be shows like this, and you can see so many free courses out there, like each of having 4 to 6 hours, and you can explore these things as well. How to heat extensor work, fluid statics, fluid basics of turbulent flow. So these are the free platform, and you can explore these things. If you want to explore the meshing as well, here it is. We can go through meshing. So and as well as fluid meshing, and also as well as space-time geometry is out there. You can have that as well. So you can see that as fluid meshing, watertight geometry, how to do this, and how to do this. So many tutorials out here as well. You can explore these things, which is free resource if you want to know about much more about them. So that's it about here. So then we check the skewness of quality of mesh. So in this meshing, it will automatically enable here that you can see. Here you can um, the minimum orthogonal quality is here, and so we can go through this, and the value will be given by. Yeah, you can see that 740. So you can directly click on the check mesh, perform mesh check, and you can see the minimal volume and maximum volume like this will be. Here you can see one of those platform. This um, now these areas are well, it will be automatically enabled here that what is the origin and as well. If you can have here as well. It will be here, and you can check that origin now is 40 count. So it's a factor that 0.58, and it's also So you can see the surface mesh. After doing the surface mesh, you can see the skewness like this. You'll get this skewness pattern. 135 is the skewness here. So after doing this quality check, it should be enabled. But I don't know it. After doing this, you can see the face area and face sample, and you can explore these things. Any other doubts?
Sir, excuse me, sir.
Yeah.
Sir, while giving the minimum maximum values in the sizing, at that time it will show some error that the minimum maximum value is not with the limit less than like that. What does that mean?
Yeah, it mean what about the geometry and what are the values you given?
Uh, Sir, actually, it is the tire wheel where we
Okay.
give minimum value from 10 to 50 mm, sir. Minimum 10, maximum 50 mm, like that. For the curvature at the
Okay.
radius less than 10 mm, 10 degree I will give. So at
Okay.
the time it will show such error that the value does not meet the limit. So is there any calculation to do minimum maximum value?
Not like that. We can have like in moment self thing. If it should be inside of it, you should compress that. The maximum should be inside of a particular a distance between the layers. If it's like a layer having, if it's like a part having something, if you consider this as a thing, consider. Yeah, if you consider like this, and
Yes.
I'm giving the maximum, the minimum value is like exceeding this limit. If it is
Okay.
15 mm, and you give this, the minimum value is like more than 15 mm. So the minimum
Okay.
value should be less than this face area. The lowest or no, the smallest
Okay.
face area should be between the smallest face area. So it would have to be adapted like that.
Okay. Okay. Okay, sir.
So
Sir,
if
also
there
while
is,
going for that revert and edit,
yeah.
if in case of the cell size is more than 80 lakhs, like that, at the time it is while giving the revert and edit while we are editing, and after we are meshing, it will the entire window will while doing the meshing, the entire window will close automatically, sir. What is the reason for the? Then we are going for the meshing, and we have to come from starting, like import geometry like that.
What the value is given, then it will
You
be
mean
that
the revert uh,
sometimes,
while revert and editing, sir?
yeah, what will be edited this particular area, what the
Okay.
value you given.
The same, sir. The same thing I am telling for the tire and the car region.
Okay, okay.
If some error is showing now, if I am going and editing in the existing thing, then I am meshing now, the entire window will suddenly close, or then I have to start from the beginning, sir.
Okay, I think it will
Uh,
be corrupted or thing. So if that happens, go to a new workbench and import
okay.
that geometry and then
Okay, sir.
start with your specifically giving you some values.
Okay.
Okay, sometimes it's gonna be like that. And save the workbench file as well. Sometimes without saving this workbench file
Okay,
or
sir.
continuously doing simulation or meshing on a particular file will sometimes exit the point itself. So,
Okay.
so the problem is like that. Okay,
Okay, sir.
keep that by doing this.
Thank you, sir.
So any other doubts, guys? We can wind up this session. Hello.
Sir, last one doubt, sir.
Yeah. Okay.
Sir,
Okay.
if the geometry and meshing we are completing after completing successfully, and we
Mhm.
are going for the setup, in the setup only we are varying the velocity, yes, sir. So at the time we will make a duplicate for that thing, right, sir? For doing different simulation based upon the velocity change only. But the mesh and
Yeah,
geometry will be common, right, sir?
yeah.
So at the time also, why it is giving error to the original file, sir? While giving if you are going for different velocities, if you are
Uh,
going for the fifth velocity from 20, 30, 40, 50 like that, after completing all the velocities, while we are going for the 60 meter per second, at the time it will make error to the main file also. So how to
so I think the
uh,
problem with the licensing file. So which
okay, sir.
software you using? Is a research or a student version? Which one you are
So
using right
it's a
now?
research, sir. College research
Okay,
license only.
research license you are using. So
Yes, sir.
sometimes it happens like you should have to save this file as a new file. Okay,
Okay, sir.
particularly we doing on a particular workbench, sometimes this type of error will be happen. So in days of working, so if I'm going to do a simulation with the days of working, like from Monday to this day, and the same file is there, and
Okay, sir.
there will be some error. You please do it, save this file as a new file and do
Okay,
the
sir.
simulation. Sometimes
Okay.
that error gonna be changed, or
Okay,
else
sir.
I think you can do another workbench
Okay.
and that's something different.
Thanks. Thank you, sir.
Sir, there is sometimes show a message that failed in handling cortex or fluent command message workbench error. So, sir, this is related to any problem in mesh or any other when the message come that failed in handling cortex or any other things. Is this related to
Can,
mesh?
can you share that snap of that error?
Yes, sir.
Can you share the snap of that error or the photo of that error?
Yes, sir. Sure, sir.
Yeah, okay. Can you share it on the WhatsApp too or on the stage meeting as well?
Sir, what is mean by star stepping case error, sir?
What?
Uh, one error will arise like that. Star stepping case error arises like that.
I didn't know. Can you share that picture so that I can? I didn't even get that type of error. So that's why. So please give that error snap so that I can look on that and we'll get back to you.
Okay, sir.
Better. Okay.
Sir, I
Even
just shared the
share.
picture in the group, sir.
Okay. Just one. Okay. Is this a student version, sir, or it's a research version?
Sir, licensed version. Actually, this was provided by my lab. This is licensed version.
License one. Okay. If research one. Okay. Okay. Let me see that, and we will get back to you after connecting with our team. Okay. That's good. No problem. Yeah. And I will get back to you, sir.
Okay, sir. Thank
I
you.
didn't even get this type of error. So I will look on that and I will get back to you on tomorrow session or else I can text you in the group as well.
Okay,
Uh,
sir. Thank you.
Sir, in
Yeah.
is there any session regarding this hands-on, sir? Can you show some rotating object tutorials?
Yeah, we don't plan to that yet. I didn't go through that yet.
Okay, sir.
So for tomorrow, session, I'm gonna be going to have some knowledge about what the type of turbulent models we using. So
Okay,
we
sir.
don't plan that yet. If we plan, sorry, no,
Okay, sir.
no
Thank you,
plan
sir.
for that. Yeah.
Thank you, sir. Okay.
Any other?
No, sir.
Are you there, sir? Hello. So let me talk with professor and then we can wind up the session.
Okay. This session has been over. The next session will start at 2:30 p.m. after the lunch. Thank you, everyone.
So I'm going to wind up the session. So I think there's not much doubt from your side. If you have any doubt, you can text me on WhatsApp or else you can call me. So thank you everyone. We'll meet again.
Thank you, sir, for your valuable post. And the next session will start at 2:30 p.m.
Yeah, okay. Bye.